Recording? Yes, thanks. All right, so I'm Iris. I'm from the Student Initiative for Open Science. We're based at the University of Amsterdam, but now we're doing everything online, so we can do a lot of really cool online talks. So we're a for-student, by-student initiative, and we really want to invite students to get involved into open science and also practice open science themselves. With SIOS, we have been doing a series of practical skills, open science practical skills. And now we have JASP as a subject. So we asked Koen, who works with JASP, to kind of introduce what it is and how you can use it and why it's great to use when you want to practice open science, but maybe you're not quite ready to use a programming language. And if you want to join SIOS, we actually have a lot of spaces. So if you're a student and you're interested in becoming part of this initiative, I'll put some links in the chat, as well as the lecture slides for today, so you can see those as well. And I think that's it. Thank you so much for Koen for doing this lecture. We're really excited to see what you have to say.
Thank you, Iris, for the nice introduction. I'll start sharing my screen so that you can all see that as well. Yes, so today I'm going to talk to you about JASP. Maybe a little bit of a small introduction about myself, if I can get the screen moving. There we go. Well, my name is Koen Derks. This is me on the screen and also on the slides. On the slides in pre-corona times, in the sun still, but now here at home. So I studied psychological methods at the University of Amsterdam, graduated from this 3 years ago, and now I'm doing a PhD at Nijrode Business University in Breukelen in the Netherlands. And I am doing that partially at the University of Amsterdam. Besides that, I also work with JASP on developing JASP further, together with the core developers at the University of Amsterdam as a side role, but also for my PhD project. In my PhD project, I researched the application of Bayesian statistics in an auditing context. So I kind of strayed away from the psychology from my previous study, and now I'm doing auditing research. But since I work a lot with JASP, of course, I was invited to give this talk, and I'm of course glad to give you guys an introduction into, well, first of all, what JASP is. Second of all, I thought it was good, since this is of course an open science lecture, to also tailor it a little bit to how can you use JASP to perform or to perform in open science. So how does it facilitate some ways of open science? And we're going to do that using a little bit of a theoretical, but also a little bit of a hands-on demonstration. So therefore, I thought it was good, since it's going to be a little bit of a hands-on demonstration as well. If we download JASP, if you want to, of course, if you want to follow along with the presentation, then you can download JASP from JASPStats.org. Because I will be performing JASP demonstration on screen in a bit, and so you can tinker along if you want to. But I'll give you a little bit of time before going into the JASP demonstration. I'll first talk a little bit about open source software. JASP is open source software, what it actually is, why open science can benefit from it, or at least my actual views on it in that sense. So what does it even mean, right? Open source software. What does it mean for software to be open? We can very plainly start with the definition from Wikipedia, which says that if I read it, open source software is basically software released under a license in which the copyright holder grants users the right to use, study, change, and distribute the software to anyone and for any purpose. Well, it's a long definition, but I usually translate that to 3 core points of what I see as open source software. It's free, it's transparent, and it's changeable. And so what I mean with that, I'll explain in the next slide. So free is the most simple, right? So you don't pay any money for it. It's free. You can just download it, get it on your computer, and use it right away. It can also be shared with anyone, because anyone that wants to download it can download it for free. Simple. But transparent gets a little bit more complicated. What I mean with transparent is that the source code, right, the code upon which the software is built, is publicly available in the sense that you can find it and look at it if you want to. It can therefore be studied if you really want to, or scrutinized by the community. And so if there are any changes there or mistakes in the code, everybody is able to see that and give suggestions to change it. Well, how does this code get publicly available? It's usually through some kind of code hosting platform like GitHub. Some of you may know it. There was also a previous lecture on GitHub by Julia Haaf, I think. I'll have the link in the slides to that in a later slide. Usually it's done via such a code hosting platform, where if you go to this platform, you can literally see inside of the code, and you can find anything that happens in there. I'm not going to show it, but if you go to the JASP GitHub page, you can actually, for example, find JASP there. So that's transparent. And what I mean with changeable in that sense is that the source code can be changed, right? So if there are any errors, transparent was you can find them, changeable is you can actually change them. Whether it is because you take the source code and adjust it yourself, or because you make a contribution to the existing software, the source code can be changed by developers or the community. And that's also a very important aspect of this open source term that I think at least is very important. The community can contribute to the existing software in that sense. So these goals, or like pillars of open source software, they fit, of course, seamlessly with the goals of open science. Right? If you look at what does open science aim to achieve, open access, data, materials, pre-registration, it tries to be transparent in that sense. And open source software is, of course, built on that very pillar of transparency, which enables the scientists, of course, to make their whole scientific process open and transparent, from like data analysis, data collection, maybe even if you pre-register a study even before that, of course, to the entire endpoint. And open source software is kind of the vehicle that allows you to perform this open science practices. So in order to illustrate its prevalence and maybe to inspire you to read up on some open source software yourself, there are some open source journals that are, these are two that I just found as well. This Journal of Statistical Software is a highly respected and very nice journal. There's also a paper on JASP actually in this journal, which if you visit the link in that slide, will guide you through it. It's more of a technical paper on how JASP works in that sense. And there's also, for example, the Journal of Open Source Software, which has a very appropriate name. But now that you have a little bit of a feeling of how open source software, what defines open source, right? How does it lie in the scientific community? What can you do with it? And why is it important for open science? It's, of course, time to introduce the star of the show, JASP, which is, of course, a statistical software program at heart. But it's built on these pillars of open source software, right? So it is transparent, hosted on GitHub, changeable for everybody to see. A little bit of information about JASP itself. What does it even stand for, JASP? Those 4 letters. There was a long time rumor that it stood for just another statistics program, but officially that has been confirmed false because it stands for Jeffrey's Amazing Statistics Program. Jeffrey's, of course, being the person that wrote, that founded most of the current Bayesian methods. JASP was founded in 2013 by Erik Jan Wagemakers, professor at the University of Amsterdam, where it is also still maintained by a core team of 4 developers that are programming in the basement of the psychological department's psychological methods department that are working on maintaining JASP. There are a lot of PhD students that contribute alongside those core programmers to the development of, for example, extra functionality in JASP. And there are, of course, a lot of volunteers all over the world that help us in beta testing JASP for upcoming releases, finding bugs, finding issues. So we aim to be a really community-driven project in that sense as well. But, well, why use JASP, right? Because, well, there's existing software as well. I always see it as like the best in both worlds in that sense. The best of both worlds, I should say, in that sense. Because if you have SPSS, for example, on one spectrum, this is what, well, most of us get taught, right? It's very easy to use. It has all these nice drop-down menus, very point and click. And so you don't have to know any code to do SPSS. It's nice, but it's expensive, right? You need a license for SPSS. And if you go outside of academia, you will probably never have a license for SPSS on your computer again. So, well, might not be useful then as well. What is the alternative? If you are a little bit more into programming, you could go to learn R. R is a free programming language, does all of the statistics, of course. It's open source, but programming is hard, right? It has a very steep learning curve. And so it takes a lot of time to become like a good programmer in R, which most of us don't really have on our hands all that time, right? So JASP is the best of both worlds, as I said. It's free, it's open source, right? So everybody can always download JASP. You don't need any license for it. And it has this easy and user-friendly point and click interface where you don't need to know any code to perform your analysis. So in summary, what does JASP give you? It does codeless state-of-the-art analyses, right? So first of all, it has all the classical statistics that we're used to from programs like SPSS, but JASP also offers a variety of Bayesian analyses. It's actually built, one of the foundations is also the Bayesian analyses, as is reflected in the name. So it's specifically focused on those things. And then it gives us a user-friendly interface to perform these analyses, right? So without any code. What is nice about JASP is that it also dynamically updates our results, which I will show how that works later in the presentation. And we can, for example, clearly annotate our results for communication. Also more about that later in the presentation. So third point there is that JASP is developed for publishing your analyses. So it is integrated with the Open Science Framework. And I heard there was already a question about how do we upload it our JASP Fast Open Science Framework. We're going to show that today. It also supports APA format tables, right? So you can directly copy any output, also graphs, by the way, from JASP directly into your Word document or paper that you are writing currently. So it's built to be user-friendly and publish and share your results in more ways than is actually shown here, but this is going to be later in the presentation. So before I go to that slide, where I show you how we can use JASP for performing open science, I think this is the point where most of you should have been able to install JASP on your computer. And so if you want to tag along, I would say let's just take a look at it on screen as well. And well, if you want to go ahead and follow the examples that we give, you can open it on your own computer. If you have two screens, by the way, otherwise you won't be able to see what I do. So if I open JASP, switch to that, this is what I see. This is the welcome screen of JASP, and it is basically divided into three important parts for now. What we see on top is a bunch of grayed out icons, saying descriptives, t-tests, ANOVA, for example. I can zoom in a little bit maybe to show you better. But I can't click on this yet. This is what we call different modules. And if I load in a data file later, I will be able to use the analyses that these modules offer. For now, let's just take a look at them and realize that they're there. What else do we have? We have this menu button in the top left corner. If I click this, I get a whole list of options over there. It's open, save. We also disregard these for now. It's just important to know the menu is over there. Then, the third part from the interface, we have this plus icon. If we click this plus icon, we get all the additional modules that we can add to our existing modules. Right now we have the default modules, which are still grayed out. And this is all the extra functionality that JASP has to offer besides the existing ones. So for example, there is a module for machine learning, which I like very much, or even to learn Bayesian statistics if you are new to the Bayesian family, I would say. So we have a lot of added functionality that we can add to the existing modules. For now, also disregard that. We're just going to take a look at the interface, or actually, well, we did that. So now that we have opened JASP and got a little bit of a feeling of what it looks like, now it's time to show you that slide of ways that we can use JASP to perform open science. And I have an example thought of, which has a workflow in which we can go through all of these examples using JASP. And the examples that we're actually going to go through are, we are going to see how we can replicate other research analyses using JASP. You can see how we can annotate our analyses, export our analyses, and share our analyses freely. We're going to see how we can use a feature that is called synchronization to, for example, also replicate an experiment using the same analyses as other researchers. We can see how we're going to, we can look at how we can share our analyses via the Open Science Framework. And of course, a benefit is that the community can contribute to the software. And I'm going to show you, of course, how you as well can contribute to JASP if you want to. So for this entire workflow that we're going to go through, I have a nice example. So suppose that you are reading your introductory statistics book, and it's in particular, the book that you're reading is The Introduction to the Practice of Statistics by Moore et al. It's a statistics book. And in this book, you read an experiment. You read about an experiment where researchers have measured two classes of children, and they were interested particularly in how well these children performed on a reading test. And one class of these children, they gave something which the book calls directed reading activities. So I guess that would be some of a reading enhancement class. Anyway, they did this, they gave these directed reading activities to one class only. And they were interested in, well, does this improve the reading capabilities of these students? They didn't say the age, but I put like a baby there. I'm sure it was that age. And they did this experiment, and they found this p-value. P-value was 0.030, which, well, they concluded that these directed reading activities did have a positive influence on these children's reading abilities. But you are, of course, an open science advocate, right? You're reading this and you think, hey, is this true? I should check this. Or maybe you're even a little bit of a Bayesian and you think, well, this p-value, how much evidence does this actually give for the alternative hypothesis? Right, so you are thinking, okay, if I want to find this out, I should maybe perform a Bayesian analysis using these data. Well, this is how I want to illustrate my first benefit of using JASP for open science, is that you are able to, for example, replicate results from papers using a module that you can add to the main modules that are already there. And it's called the summary statistics module. And the summary statistics module allows you to take summary statistics from a paper and recompute the results in a Bayesian way. It's super easy. And well, let's just look at how we do it. We investigate this paper by Moore et al. And we find that they have performed, well, they have gotten these results. They have two groups, a treatment group in the first place, which has 21 observations, a mean and a standard deviation. A control group that had 23 observations with also a mean and a standard deviation. And we see the hypotheses that they tested. And so, importantly, they did this t-test and they calculated, well, difficult formula, a t-statistic of 2.31. That's the important part, because that's what the p-value is also based on, together with the sample sizes there. So using that summary statistics module, we can take this information and super easily recompute how much evidence there is for that hypothesis that they're testing. A Bayesian statement made with just this information. So let's go ahead and do that in JASP. If I switch to JASP right now, what I will do first is go ahead and add this summary statistics module to my JASP. And this gives me, as you can see here, the summary statistics module is now enabled. Why is it enabled? Well, it doesn't require any data for it to function, since it only takes the summary statistics. Now I can actually click that module. If I click it, I can see all the different analyses that I can reperform using summary statistics. So without loading in data, I can already use JASP. So I know that these researchers did an independent samples t-test, and I want to recompute what is the evidence for that. So I click that independent samples t-test section. And what that gives me is immediately it opens the analyses, and I can see that this analysis, the screen that I'm seeing now, is basically divided into two parts. Right? So on the left side, over there, we have the input screen, where I can enter, as you can see, my summary statistics, the t-value, the size of group 1, the size of group 2, and what the hypothesis is. And on the right side, you see we have the output screen. So this is where my results will be. And the nice thing about JASP in this case is that these two, the input screen and the output screen, are inherently linked. So that if you change any value in the input over here, it will automatically change the table depending on your changes in the value. We will see this in action because we can actually recompute this analysis from this paper using these statistics. So we know from these results over here that our t-value is 2.31 and our n's are 21 and 23. We can go ahead and enter that into JASP. So I can enter t is 2.31. This n was 21, the group size of group 1, and the group size of group 2 was 23. Now let's see if all the options are correct here before looking at the output, because I'm still missing something. The alternative hypothesis in this case was that the first group was had better reading activities than the second group. So I have to click the alternative hypothesis here that group 1 is higher than group 2. And as you can see, the results section here automatically updates with that information. What do I see now? I see the t-statistics that I've provided and the sample sizes. I also see the p-value that we got from that paper. So now we actually know that that p-value was correct that they have that they reported. But what I also see now is the Bayes factor. The Bayes factor is basically a Bayesian statement about how much evidence there is in favor of the alternative hypothesis versus the null hypothesis. This Bayes factor tells us that the alternative hypothesis, so the fact that these directed reading activities did actually make these students better at reading, is 5 times more likelier than that it did not. So here you have converted these summary statistics that you got from this paper into an actual Bayesian reanalysis. And so therefore, congratulations, you are now fully Bayesian. Alongside this Bayes factor, we can actually see the prior and posterior distribution very easily by clicking on that plot figure. With me, it's a little bit large because I've zoomed into the screen a little bit. But here, this allows you to see what the prior and posterior distribution used in this analysis is. The prior distribution influences the value of the Bayes factor in this case. And something that you can check with this Bayes factor robustness check. So if I click away this, you see it automatically updates again. The plot is gone. And if I click this Bayes factor robustness check, this gives me a figure that shows the Bayes factor for the alternative hypothesis under every value of the prior distribution. So it performs this analysis with every possible value prior distribution and plots the Bayes factors as a function of the prior width. So this I can use to find out that the evidence that I got was in fact moderate, 5 times more likely we consider it moderate, but it was relatively stable alongside all the different or the reasonable values of the prior that I can use. Well, this shows, first of all, how easy it is to use these summary statistics without any data to recompute values in a Bayesian way, a p-value, for example, or a Bayes factor, and also how you can easily update this output section by clicking on the different plots section, plots boxes. So that's great. We've now performed a Bayesian analysis, and we've reproduced the analysis from the article using Jasp. But suppose that we're still not really, well, still a little bit suspicious maybe, or maybe we just want to verify, right? Oh, I see a question in the chat as well. So it's a good question. The question is, I'm wondering what the Cauchy scale 0.707 means. So this is in fact the prior distribution that we use for estimating the effect size in this case. So this dotted line represents the prior distribution, which you can adjust, in fact, under this prior header. So by default, we choose a Cauchy prior, which is a type of probability distribution that fits particularly well in like a t-test context. And this is the default value that is commonly used for it. You can also adjust the prior distribution by choosing an informed prior, for example. By clicking that, you can choose whether you want a Cauchy prior, a normal prior, or t distribution as a prior. This is also reported in the JASP file directly, right? But more on that later, on what the JASP file also contains. Okay, so let's go back to that slide, because suppose we weren't really sure about that, and we actually, or let's just say we're really interested in this experiment, right? So we just want to reperform it. We want the original data. Yeah, this slide is gone. So, wait, I need to go back one slide. So suppose that you really want to have access to the data. And so you email the original authors of this paper, and they and you ask, okay, do you have the data? And can you share the data with me? And this is how this scenario is how I want to illustrate the second point of how you can use JASP for open science. Because suppose that they have also used JASP to perform their analyses, then in fact they can send you their entire package of data, analyses, results, and comments into a JASP file itself. So in fact, if I go to JASP, then I am able to also annotate my JASP files, basically say I want to give comments on it, by clicking on this little arrow next to the table and saying add note. So that gives me a little space to write my text. And in this case, I can, for example, use it to say that the alternative hypothesis is many times more likely, well, moderately, than the null hypothesis. This way, if I now save this JASP file, which I can actually do by going to the top menu, clicking Save As, and then going to my computer and browsing a place where I want to save my file, I can see that the file saves as a .jasp file. What is contained in this JASP file is, first of all, your data set that you have used, your analyses that you have performed, the results section, and also the comments that you have made in this JASP file. So by saving this, for example, on my desktop, and I'm calling it hello, then by actually closing this JASP instance, so I'm just going to close this file by clicking close now, and then I can reload that JASP file I just saved by going to open and then computer, where I can browse to a JASP file or a data set. In this case, it was on my desktop, it was called hello. If I open this, I automatically get, in this case, there was no data, but the data would be attached. But the analysis, the results, and also the comments that I've made with my results. So this allows you to very easily annotate your analyses, export the data, the analyses, and the annotations to a JASP file, and share that JASP file with, well, the world or anyone. So that is a very, well, I guess, a good benefit for open science in this case. This JASP file can mainly be opened by anyone that has JASP installed, right? But can also be viewed without having JASP installed. And that's where the Open Science Framework later comes into play. But for now, suppose that we have actually gotten this JASP file from those researchers that we contacted earlier, right? And you can also pretend like you've gotten this JASP file, because you can find it inside what we call the data library. Data library inside JASP is a collection of data sets and examples that are built in to basically show the functionality. And the data, the example that I talked about earlier, is also featured in there. So I have this JASP file loaded now. What I'm going to do is I'm just going to close it again. So start a fresh instance of JASP by clicking close. And now it's gone. So I can open this data example file that I was talking about. If I go to the hamburger menu here again, click open, and then hover on data library. And that gives me all the categories that I can choose an example file from. And in this case, the researchers performed a t-test. So if we click this section, we get a lot of example files. And scroll down to show even more, which feature annotated analyses. And you might notice that the one above here shows directed reading activity. So that is actually the JASP file that these researchers emailed to us. We can open this just by clicking on this green logo with the data set. By clicking that, I get automatically, first of all, the annotated output that the researchers have provided. So I can see exactly what the researchers wanted to show, what the variables they have used, the results over here, and also, I will zoom out a little bit, all the statistical results by itself. If I click on these bars, these are the analyses they performed. So by clicking on them, I can actually see immediately what variables have been used in what analysis and what options were selected by the researchers. So besides that, so I have the results or the analysis that they performed, and I have the results and the output. If I click on this arrow in the middle, then what I will be, not the arrow in the middle, the arrow on the left, then what it shows me is that it also loaded the entire data set that the researchers have used to perform these analyses. So here you can see what JASP looks like with a loaded data set. So you see every column, well, as you're used to probably, is a variable, every row is an observation. So the data is packaged alongside with the results, the analyses, and the annotations, which makes it, of course, ultimately transparent. Make sure that you anonymize your data whenever you share your data in that case, right? Because the data is also packaged inside the JASP file. Okay, so we can actually share that with anyone that we want. All right, so we've done that part of the slide. So after showing you how you can easily save a JASP file, right? Annotate your results, or also get a JASP file from researchers, I'm going to show you a nice little feature that you can also use to perform open science, which is the synchronization feature, which is relatively unknown, but it works really well and it's really nice. So examples for where you can use this is, for example, to replicate an experiment by rerunning the same analysis as a researcher with newly collected data. Or pre-registering your analysis using a mock data set. So I will go over these examples in a bit. So what I mean with this synchronization feature is the following button. So when I go to the left, the top left, you see that I can hover over the menu, And now I can find sync data. And if I go to computer, apparently I can find a data file that I can sync it with. Well, let's just keep it that for now. Suppose that I have actually, I look at this p-value obtained by these researchers, I think, okay, 0.013, and then I look at the base factor I computed earlier, right? It was 4.7. I'm not really convinced yet, right? So I really want to actually perform my own experiment to replicate the experiment by the researchers and to validate their results. Okay, so suppose I have actually I've done this. I did the exact same setup as these researchers. I've collected a lot of new data, and I've posted them here. Well, as you can see, we have 102 new people that we have tested, and so kind of try to replicate this experiment. So what we can do now, or at least I can do now. Unfortunately, you can't do this part of the thing, except if you make a new data set, just make sure that the variable names are the same across these data sets. Because what you can do then, and look at the results once the data is synced, you can actually say, sync the data set, which file, well, in my case, it's in this folder, and it was replication DRP. If I click this, well, the JASP output automatically synchronizes that same analysis that the researchers used, but now with my new data. And you can see that, well, my p-values in this case are quite small. So there's probably an effect. The researchers also did a plot. Well, we can see that with confidence intervals, right? We can see that there's a pretty large difference between the two groups. But right, we want to say that it is a replication study, so we should probably adjust the outcomes of this test over here, because the p-value is now not 0.013, it's something different. We can do that by also clicking on the note again, and as you can see, we can now write and adjust first of all the t-value over here, because in this case the t-value was minus 4.718, and I can also adjust the p-value, which was now smaller than 0.001. So this is how we can also replicate that experiment using the same analyses. And we can, of course, say that this was by clicking on edit title, we can say that this was a replication experiment. And now we have basically performed our entire replication experiment using JASP, gotten the summary statistics from a paper, asked those researchers, can you provide it? Using JASP, loaded in the analyses that they have provided, and synchronized our data with that analysis to perform a replication. Nice. So what I can do now is I can save this JASP file, because I don't want to lose my stuff, so I can click Save As again, click on Computer, well, save it on my desktop, it's fine. I'm going to save it as directed reading activities.jasp. So if I click Save, well, that actually, it says Save in Dutch. Then it starts saving my entire JASP file to my desktop in a .jasp file, right? So this is how I want to show actually my fourth way how you can share your JASP files with the world. So the Open Science Framework, which was probably already known then, is able to upload the JASP files and also render them on the site itself without you having to worry about somebody having installed JASP. So suppose that my replication experiment, I wanted to put it on the Open Science Framework as a .jasp file. So anybody that downloads it immediately has the data, the analyses, the annotations, and the results. Then I can go to the Open Science Framework, which I need to start my internet for. And then I can actually try and upload that JASP file to the Open Science Framework. So I believe it was this. Yeah. I actually created a project for this. I'm well prepared. So if I have this existing project, and remember that the JASP file had all the annotations and all the text in it. I see that I have this project here, nothing is in there. But if I drag or upload just a file to this storage, right? So as you can see, I dragged this JASP file from my desktop now to this storage thing, then it starts to automatically upload it. There it is. And now everybody that wants to see it just has to click on it. And what they get is an automatically rendered version of the entire JASP file, including all the results. You see here is my p-value smaller than 0.01. I didn't do anything Bayesian, unfortunately, yet. But what you can also see is all the plots, all the descriptive statistics that were done previously. So it's very easy to share your results via the Open Science Framework without anybody or without the viewer needing to install JASP in that sense. Ultimately transparent. But if they want to, they can download the JASP file, they have the data, they have the analyses, they have the annotations, they have the results. The entire package in one, actually.
There's a question in the chat.
I see. The question is it possible to share your results without sharing your data? The current way that JASP saves the JASP file is with the data. So in that case, you should probably or anonymize your data or remove, I guess, if that's possible, unwanted columns. But yes, I mean that this is of course a problem still with sharing data. If it's not allowed, then well, it's hard to share the data, of course. Currently, this is not possible.
One more question asks about, can you save the results as an HTML file?
Yes, that's actually true. I will illustrate that for a bit. So suppose that we go back to that JASP file now. Right? I have the replication file. Then what I can do is go to the top left menu again. And you see there are a lot more options there as well. I can, for example, export the data that they've used just to an Excel file, for example, or export the results. This is how we export our analysis to an HTML file without sharing the data. Yeah, very nice. You see, I learn something every day. So if I do this, then I get to directed reading, save this HTML file on my desktop. And if I open this, just clicking it, then what I get is just a kind of web page, right, with the annotated output. And as you can see, everything is there. That was also on the OSF, but now you don't have the data. Very handy trick. All right. I see we don't have that much longer anymore. So what I want to emphasize is that the open source nature, of course, of JASP allows the scientific community to also contribute to the software. And well, you are the scientific community, right? So if you would like to contribute to the software, if you have found a bug or anything, or if you even have a suggestion for improvement, we're always willing to look at the suggestions and what we can implement, of course. So in the slides are also a couple of links that you can follow. For example, we have an issues page that you can look for bugs and suggestions. Or if you want to get involved with JASP in a little bit more of a hands-on way, that you can apply to become a beta tester for new versions if you want to. So there's also a manual on that via the following link. Yeah, if you look, if you want to become a beta tester, it would take maybe a little bit of knowledge through GitHub. Luckily, there's that SIOS presentation from Julia, which is here actually findable under the link in this slide. Lastly, what I wanted to say is that there are many resources for JASP if you want to get to know the ins and outs of it. There's a free book about JASP even from that you can find on the JASP website. It's by Mark Go-Simpson. And he has compiled a whole student guide about how to use JASP, examples with data sets. So that is a very nice starting resource. There's also an active community forum that we look upon frequently, which you can find under the following link, the JASP Base Factor forum. Or if you're interested in anything else, you can find, of course, something under the link on the website where you can find a lot of JASP materials. And always, of course, if you have anything that you want to inquire about, you can also email to info@jaspstats.org. I'll make sure that the email address gets there as well. But yeah, this was the presentation about JASP. I hope that you have learned a little bit about what the program is, where it came from, how it fits into the open science community, and what it can mean for that community. And also maybe how fun it is to be a Bayesian and to recompute these things using summary statistics as well. Well, thanks for the attention.